Title: GABInsight, Exploring Gender Activity Binding Bias in Vision Language Models. The paper introduces the concept of gender activity binding (GAB) bias in vision language models, VLMs, which refers to the undesirable association of a factor with a gender according to the model. The authors have created a dataset known as the Gender Activity Binding (GAB) dataset, comprising AI-generated images depicting various activities performed by men or women in different contexts, each accompanied by a descriptive caption. They benchmark the performance of 12 renowned multimodal foundation models and assess their performance in terms of text-to-image retrieval, image-to-text retrieval, and recognizing activities on the GAB dataset. The results indicate that VLMs experience an average performance decline of about 13.2% when confronted with gender activity binding bias. The GAB dataset is created using DALL-E to generate images depicting various activities performed by men or women in different contexts. The activities included in the GAB dataset are sourced from various places to encapsulate societal gender stereotypes and other activities that are statistically biased towards a specific gender, as observed in the LAION 400M dataset. The authors carry out supplementary experiments to investigate the binding bias in VLMs' capability to comprehend activities and the bias present in their text encoders. They delve into the insights that can be derived about how VLMs internalize this bias and its impact on the shared embedding space of VLMs. The study is the first to delve into the origins of the association between genders and activities in vision language models by conducting a thorough analysis both image-to-text and text-to-image retrieval accuracy of VLMs. It encompasses not only straightforward scenarios involving single individuals, where VLMs demonstrate high accuracy for both genders, but also more complex situations with individuals of different genders. This comprehensive approach allows us to isolate the impact of the complexity of the scenario on performance decline and more accurately measure the gender activity binding bias. This research paper delves into the issue of gender activity binding bias in vision language models, VLMs. The authors identified three categories of biased activities: stereotypical, everyday, and LAION 400M. They provide a comprehensive report of each category in tables 2, 3, and 4, detailing the expected subject and amount of data in each setting. The authors experiment with various image generation models, including diffusion models and DALL-E3, to generate images that represent the intended activity. They choose DALL-E3 as their final image generation solution due to its improved quality of compositional generation. To mitigate bias in VLMs, the authors discuss several approaches, including orthogonal projection, additive residual image representations, learnable prompts, and fair dataset creation. However, each method has its limitations, such as stripping away useful nuances, requiring extensive and diverse data, or introducing new biases. The authors evaluate the performance of VLMs on image-to-text retrieval and text-to-image retrieval tasks. The results, presented in figures 5, 6, and 7, show a performance drop between scenarios for each model. The models exhibit an average accuracy of approximately 90% in identifying the correct image that represents the gender of the individual performing the activity. The authors also discuss the limitations of their approach, including the potential for overfitting to adversarial objectives and the risk of introducing new biases. They highlight the need for further research to develop more effective methods for mitigating bias in VLMs. The paper concludes by emphasizing the importance of addressing bias in VLMs to ensure fairness and accuracy in downstream applications. The author's work contributes to the ongoing effort to develop more robust and fair VLMs. In addition, the research investigates the bias in binding gender with certain activities in vision language models, VLMs. To gauge the model's understanding of activities, the authors collect several activities performed in the same environment as the reference activity for each activity in the GAB dataset using GPT-4. For each image in the GAB dataset, a caption is created from the reference and associated collected activities, arranged based on their matching score to the image. The results, presented in tables 57, show that VLMs can recognize the performed activity in image-to-text retrieval tasks to some extent. The findings suggest that VLMs can recognize activities in image-to-text retrieval tasks, but the performance varies across models and datasets. The results also highlight the importance of considering the context in which activities are performed, as the model's performance improves when the activities are gathered from the same environment. The study's limitations include the reliance on a specific dataset and the need for further investigation into the model's ability to recognize activities in more diverse contexts. Future work could explore the use of more diverse datasets and the development of more robust models that can recognize activities in a wide range of contexts.